Hi, today I'm going to show you how to make a Bluetooth controlled robot. You can control this robot through your mobile phone or any device that has Bluetooth capabilities. You can control it through an app, through a phone app, and this will send data over Bluetooth to the Arduino's Bluetooth chip that we have here, which is HC-05. Let me actually show it to you by removing it first. I made everything socketable on this project. Let me show it to you. As you can see, this is the HC-05 Bluetooth module that allows for communicating with the Arduino. You can also use HC-06, but the HC-06 works with 3.3 volts, but the HC-05 can work with 5 volts when it comes to the RX and TX pins. If you're going to use the HC-06, remember to use some resistors on the RX pin. I didn't use an HC-06 before, so I don't know what the value of those resistors are, but a quick Google search should probably give enough information about those resistors. So let's put it back in to the socket. So the parts we're going to use on this robot is one Arduino Nano or Uno, a perf board for the chassis of our robot. I used 12 by 12 centimeters perf board in this case. You can use 12 by 12 perf board for making this robot, but it doesn't need to be like perfectly 12 by 12. You can go up to 15 by 15. But make sure that the length of the robot isn't longer than 15 centimeters, because if it's going to be longer than 15 centimeters, it can cause the robot to not turn properly, because we're only using 2 motors here, and we only have this passive wheel right here. Right, as you can see, it's a big one. Than the other robots that I've made the videos of. I'm going to replace it with the same wheel on this to this, like so, because this wheel is basically useless. I bought it online because it was cheap, but it can't go on carpet, it can't go on bumpy roads, bumpy surfaces. It needs to be on a flat surface to go anywhere. Otherwise this passive wheel will just get stuck. So you can use 10 by 10 also if you have a 10 by 10 perf board laying around. You don't need to buy a new one, you can just use whatever you have. It just needs to be at least 10 by 10 or 15 by 15, or around that range. The length and the width doesn't really matter, because you can just combine things together, like 11 by 13, 12 by 13, 13 by 11, 10 by 15. It doesn't really matter. As long as the length doesn't exceed 15 centimeters, it should be fine. And we also use 2 motors like this, as you can see right here. These are DC motors that have a gearbox in them. They're 250 RPM and can work from 3 volts to 9 volts. In this case, we will be inputting the Arduino voltage through the VIN pin. So I made this Arduino completely socketable, and we're using an L298N in this case, because the robot is heavier than the ones that I've made the videos of. Normally on the other ones we used the L293B, because we absolutely need to use L298N on this robot, since the robot's so heavy because of all the circuitry and the extra circuitry it's got. It's got a Bluetooth chip, an Arduino, a lot of solder connections because of the Bluetooth chip here on the perf board, the L298N, the motors, the perf board, as I said. The LED system, yes, this has rear and front LEDs like a car. Basically this is just a car. You can control it on your phone through Bluetooth, and it's also DIY. There is also a buzzer that we attached here for letting you know when the Bluetooth becomes disconnected and it will start beeping. But to have the ability to silence the buzzer, we added a little switch here, so if you don't want the annoying sound of the buzzer, you can just turn it on or off from the switch. As I said, we used L298N here, the motor driver, which can handle 2 amps per channel. The L293B chip can handle 1 amp per motor. You can also watch the video that I made about L293D, B, and L298N motor drivers, and that video has a lot of information, useful information about these motor drivers. So we also need a capacitor here attached to the Bluetooth modules, 5 volts, like a little capacitor would do. I don't remember the capacity of this one. Let me try to see it. I just attached a 16 volt 1000 microfarad capacitor here on the 5 volt terminal of the Bluetooth module, because the Bluetooth module is really sensitive for voltage changes, and it can get disconnected when there's a voltage dip on the motors. There's actually a problem that I'm trying to solve and I can't figure it out. Is it because the battery pack that I mentioned in the light following robots is the problem? The XL-6009, the TP4056 going into protection mode, or the XL-6009 not powerful enough, or it's like thermal throttling? I have no idea, but when I max out the motor speed and then immediately stop it and then try to go back on the other direction, like go back for example while going front, it just completely resets the motor's speed down to 0, because I don't know why it does that, because of maybe voltage fluctuation. The Arduino's code just goes back to the loop. I'm not sure, but it just makes the motors go to 0% when it comes to the speed. Normally it's supposed to turn backwards at 100% speed, but I can't get it to work and I don't know why. It might be something about the code, because I write the code myself. I wrote the code myself, and getting Bluetooth chips on Arduino is a little bit finicky, so I don't know if I misconfigured something on the Bluetooth chip or not that causes this issue. But if you have the solution to this and had a similar problem to this while making a robot, let me know down the comments section. So as I said, we used L298N motor driver here, and it's attached with this nice little socketable cable right here. Everything on this project is socketable and removable. Both the motor driver, the HC-05 Bluetooth chip, the battery pack, the Arduino, the everything basically, except the motors, because they need to be glued on to be secured on tightly so that it doesn't just go upwards when we put the robot and it starts moving. The motors shouldn't just fall off, so we need to glue them to the perf board. But you can still remove the motors if you want, because hot glue can be removed with a little dab of isopropyl alcohol. It would basically just dissolve the glue and you'll have your motors back separated from the perf board. And we also have 4 additional LEDs, 2 red ones and 2 white ones on the front and the back, like this. These can be also controlled from your phone, like the brake light and the front lights. But it's just an extra thing. You don't need to attach them if you don't have LEDs, but if you do, it's a nice addition and it's usable in the code. The LEDs and the front LEDs and the back LEDs are attached to the Arduino's GPIO pins, and also the buzzer at the same time. I'm gonna link down the code that I wrote and the fritzing circuit diagram for this robot, so you can look at it and do it your own. If we look on the Arduino Uno side right here, we used the same mounting system as the obstacle avoiding robot as we did on that robot. I just attach a small little cardboard piece on the bottom of the Arduino Uno with a little Velcro on the bottom with rubber ties tied to the Arduino, so it doesn't damage the Arduino. No screwing the Arduino to the perf board, no gluing to the perfect, no taping it together or anything like that. You can just take out the Arduino when you want, and you can just use it without any damage to it. And we also use the same Velcro technique on this battery pack that we're going to attach on the back of the robot, and let's do a little test before testing it out on the ground. So let's plug the power connector in like this, and I'm going to be using an app called, let me see, I'm going to be using an app called Arduino Bluetooth controller. It wants us to turn on Bluetooth right now. We're just going to do that. Turning on Bluetooth. You need to power up your robot before trying to connect to it, otherwise the connection would fail and it wouldn't connect to anything. So I got HC-05, as you can see right here, already saved on this phone. It's an old phone, but it still works for controlling over Bluetooth, and it may ask a password, and the password is usually 000, so 4 zeros, or 1111, so 4 ones. So I'm just going to flip the switch. The front LEDs flash for a second because they're attached to the 13th pin, and the Bluetooth is, as you can see, flashing red right now, and the buzzer is switched off right now. But if we switch it on, we hear the buzzer beeping, reminding us that the connection is broken right now. So we click on HC-05 and click on controller mode, and as you can see, the LED on the HC-05 starts to blink very slowly, and we have a controller layout. Let's press select, which fires up the back LEDs, as you can see, the brake LEDs, and if we press start, it fires up the front LEDs like so. This square icon right here disables the LEDs, all of them, just shuts them all down. These are the forwards, backwards, left and right turn keys, and this is speed up, speed down, turn off the motors or stop, and this is the LED turn off button. So if we turn on the LEDs, we can just press on that and it would stop the LEDs. There needs to be a mapping made on these buttons, as you can see right here. S for left, I for forwards, O for right, G for backwards, L for select, and T for start, U for square, A for triangle, D for cross, and Z for circle. So if we go back on the controller interface and turn on the headlights, do we have a connection? Yes, we do, and the headlights are turned on. As you can see, if I press forwards, it's on 0% speed and the motors are not going to turn. It's just, we're just hearing the PWM tone right now. But if I increase the speed, as you can see, they start turning faster like so. Now the thing that I want to mention is, like, we're turning to left, the other motor gets disabled, as you can see. To the right, actually vice versa, it's the left and this is the right. As you can see, the other motor stops functioning and this one starts turning, but it's on 100% speed. I tried to go front at 100% speed, it completely resets to 0, like it completely turns off everything. As you can see, once I press forward, it just goes back to 0% speed. I don't get this. I'm just gonna increase the speed all the way, turn on the headlights, and go back. As you can see, it just resets everything to 0, but we may have lost a connection here because there was an immediate voltage drop when the motors were turning front. They just immediately wanted to snap back, so that might have caused some interference, and caused the interference that caused may have disabled the HC-05's connection. But let's try it again, and we're getting nothing. So I don't know what this problem is. If you know, if you like came across a problem like this, please write it down in the comments, like what this problem is. I just can't figure it out. When the motors are going front, when I just snap them, like want to snap them backwards, the voltage drop, I think, causes a loose connection, I think. But we can still use the robots. Not on 100% speed though. I'm gonna enable these. It's at like 65% speed right now. But again, once I just try to go back, it also resets everything to 0%, which is very strange. I don't get it. So forwards, 65% around speed. Stop the motors. Right, left, stop, and then backwards. That works. If I stop the motors first and I have a low speed, the motors can turn without any issues. This is through the L298N motor driver, by the way, and it's at 7 volts, driving the motors at 7 volts. I can go back at around 60% speed, 65% speed, go front, right and left, but not at 100% speed, so it's a little bit confusing. But anyway, it still works like this. So let's take this robot on the ground and test it. So as you can see right here, I have the robot on the ground and I got the Bluetooth controller right here. I'm just gonna press forward, stop, and then backwards, and then make a U-turn. And then come back, stop, make another U-turn. This wasn't really a U-turn, but it doesn't really matter for now. Go like this, as you can see. Just gonna go like this, go like that, like this. Stop it, and then go front. And then stop the motors, turn a bit, like so. You might be seeing me pressing the touchscreen a couple of times for the robot to respond. It's not about the robot responding. The program is a little bit finicky and it requires a couple of times. It requires you to press a couple of times for it to register the press and send the data over Bluetooth. This program actually removed the controller feature actually on the next versions. I don't know why they did that. It's a very stupid move, to be honest. And yeah, this app is basically unusable on the new versions. You can still open up the terminal and type out the commands right there, but what's the fun in that when you can have a controller interface like this? This is the old version of the app, by the way, because the phone is old and it runs the old version of Android. So I downloaded this app very long time ago, and it didn't get any updates. So because the Android version is old enough to not get updates anymore. So we have the controller mode right here, but on the newer version, on this app, the Arduino Bluetooth controller app, we don't. But if you type out Arduino Bluetooth on the Google Play Store or the Apple Store, there is going to be a lot of apps that are going to pop up, and you can use the other ones. On my new phone, I use another app I found from the Google Play Store, because this old one doesn't work anymore because of the update. So the other apps also have the control schemes, and some of them even have more buttons. This one only has like 10 buttons. So you can also turn off the headlights and just open them. Okay, wait a minute. And open them like so individually, or close them all like this. So let's take the robot to the desk again and finish our video. So this is how you make a Bluetooth controlled robot with the HC-05 Bluetooth chip. It's a little bit finicky to get it working, but if you have no issues with my code, by using my code and my circuit diagrams, and you don't have any issues like disconnection or like the settings just resetting to 0% speed when you go backwards when the robot's going forwards, please note that down in the comment section. I really want to solve this problem because it's pretty annoying while you're trying to make the robot go faster, but it can't, because if you try to make a fast move it would just lose connection. So it's a little bit annoying, but other than this small issue, this robot works perfectly fine. And let's turn on the buzzer right now and let's quit the app. As you can see, when the connection is lost, it starts beeping and it turns everything off, including the motors if they're running. It turned off the headlights because they were on, but if the motors are running while the disconnection is happening, it would also turn off the motors. So this is how you make a Bluetooth controlled robot. This is Arduino Atolyem. Thanks for watching, and if you find my videos useful, please don't forget to like my videos and please consider subscribing. And if you have friends that have hobbies about electronics and maker things, please send my videos to your friends, which would really help my channel out a lot. Thanks for watching. See you on the next video.